All right, hello, how is everyone doing? Fourth of the way through our XAM Summit here. So yeah, I'm Shane Neuville. Spelled it right? Yeah, Shane Neuville. And I'm with the Xamarin Forms team. Prior to being with Xamarin Forms, I worked a decent amount with Reactive UI. So I still try to champion that as much as I can, even from within Microsoft. So the talk here is going to be heavily about, reactive extensions specifically, just kind of the concepts behind that drive reactive, how they mirror to events. And then later, Michael's going to do a more extensive talk on mapping that over like MVVM and how to kind of power your frameworks for that. So to get us started with this, how many people have used reactive extensions? Just to get oh hey, that's nice. Every time I ask, there's more hands, so that's a good sign. Let's see, so how many people think I'm talking about JavaScript and React.js? Maybe that guy up there, him? All right. All right, yeah, so some of the vernacular started to clear up as well. Does anyone think I'm going to talk about observable collections for about an hour? No? All right. So along that, this frame becomes a little less relevant as the talks go on. There was definitely some confusion that started out. So I remember the first time I heard of React.js, I had been doing RxJS for some time. And it was about 5 minutes into the conversation, I realized we weren't having the same conversation. So there's not really any relationship there besides the first 5 letters. Yeah. The Angular has started heavily using RxJS, so Angular is probably more synonymous with RxJS at this point. But yeah. And then the next area where people get kind of thrown off has to do with ReactiveX and Reactive UI and sort of where those division points are. So ReactiveX is sort of a platform agnostic concept. So the ReactiveX concept is implemented across multiple frameworks. So there's there's a Cocoa, a Java, RxJS. There's a whole swath of languages that implement the concepts. So and then Reactive UI is the MVVM layer that helps plug Reactive-AX into your MVVM. So you don't necessarily need React. So when people are talking about reactive, they're not just talking about Reactive UI. They're mainly talking about functional reactive programming and how observable-based programming paradigms work. So the Reactive-X aspect is what this talk is going to revolve around, which will be a good precursor for Michael's talk later. So, oh, why did it beep at me? Hold on, maybe I don't have it highlighted. There we go. All right, so let's kind of break down. Let's break down what we're really looking at here. So let's talk about events really quick. So how do you subscribe to events? It's all pretty basic. We've all seen this code before. There you go. Pretty exciting, right? So effectively, you have your publisher on the left. You have your event, and then you have your observer on the right there. So it's your basic event notification pattern, your basic observer pattern. So this was the syntax in C#1. Effectively, the top one does the same thing as the bottom, but syntactic sugar. So let's kind of break down what an event is, right? So an event is essentially, it's a series of individual things that occur that produce data. So if I'm typing my name, I type S, there's an event, H, an event, A, an event. I think you see where all of this is going. And the representation of that data is here. So that is the sets of data that have occurred based on those events, right? So that's your event. So nothing too mind-blowing at this point. So, all right, steps to stop observing an event. So how do you stop observing an event? We've all unobserved from events, right? Like we've all said, hey, I no longer care about what this thing happens. So usually the process of figuring out how to unsubscribe from events starts with the customer complaining that your app is slow, right? So the customer files an issue and says, hey, my app slows down after using it. What's going wrong? The more I'm using it, it's not working. So first, you don't believe them. You think they've installed some like Dilbert screensaver that's taking up the whole browser window or something like that. Because when you start up your application and you use it for about 15 seconds, it's fast, right? Everything works great. It's responsive. You've figured out that it's perfect. So then you're like, all right, I guess I believe him. So at this point, you dust off your debugging hat, reread through all of Tessa's blogs on how to analyze stack frames, and you start pulling everything in. You get the stack dumps. You look at how long objects are living. You do it over and over again. And finally, you're getting down. There's lots of staring at arrows, pointing at things, and wondering what objects matter, and subtracting this from that until you finally see that there was that one line of code where you forgot to write that. You're like, oh, man. And then all of a sudden, everything starts running super fast, right? So yeah, I mean, basically, you're subscribe and unsubscribe from event, right? So this is that's the semantics of it. But the semantic, it's a little gnarly, I feel like, because one, you have to remember to do two things. Anytime you have to remember to do more than one thing, you're going to fail, usually, in programming. Plus, you have to retain your references to everything. So in order to do the importance of that second one, you need everything that's in your first one to do everything in your second one. Like you have to maintain those ideas. So in general, event management is just, it's messy. It's not the cleanest type of operation. I mean, let's say you only care about a single event, for example. Like we've all written this code, right? Where if you want to unsubscribe from something, like you only want it to fire once. So let's say like an appearing page or something of that nature, right? So you have to have the reference at top so that the closure inside has access to it. Then you assign the handler, and then you do the handler at the end. So there's kind of this excessive ceremony that comes from these set of operations. So this looks familiar. Has everyone written this kind of code before? Yeah? All right. So, and here I'm still talking about events. This is what I call my iObservable infomercial, where you do something crazy and you're like, oh my god, it's so terrible. It's not that bad. But here I'm kind of indicating all the stuff. This is in Xamarin Forms, when you're wiring up to an event. So, you wire up to the event. You have to find, OK, where's my dispose aspect? OK, it's down here. I have to make sure to dispose from the event. All this stuff is in disparate locations in your entire file. These are all these things, this ceremony you have to do with all these sort of event management systems. Look, right up there, you have to subscribe to it. Then you have your handler down here. You're dealing with the data in a separate spot, and then it's up here. It's this very disconnected experience. So here I even typed the wrong thing because I'm so flustered at how hard it is. But yeah, so I call it the infomercial. Where did the soda go? So this is still sort of, so that's the thing. So events are these singular synchronous data points, right? So you get a text changed event, and then all you have is that text change event. You just have that letter. You just have that letter S that you have to deal with. But what if you want to do more with that? Because whenever you have an event, you very rarely care about the one event, right? You care about the data set of events. You care about everything that's happening over the period of time. So what if you want to do something very exciting? So what if you want to say, skip your first 5 events, and then only care about the next 4? Then you want to debounce the events. So if they're typing super fast, only wait 2 seconds. Then let's say you want to filter out any events that are cornflower blue, just because it's a horrible color, possibly. I don't know. And then, then you want to kick off a web request, and then they start over, so you want to just throw that away. Like this type of pattern, is very common as far as your event management, especially in like MVVM frameworks and things that are more UI-based. You're always having to react against incoming data points with connectivity getting lost. So like, what if your connectivity gets lost at the web request point? How do you interrupt that web request once the connectivity is lost? How do you do that in a reliable way to that's easy to manage? So all of these concepts have very clear versions of the verbs that map to them in reactive. So these are all actual things you can use sort of in reactive to articulate all of these attempts over your data, over your event stream. All right? So what else can we do with events? Not really that much. They're very simple, basic patterns, right? So that's my teardown of events. So at this point, if you haven't really used reactive, you're probably like, oh, events are terrible, right? I've been doing this wrong the whole time. And you're having an existential crisis about all the issues that you didn't know you had, that now you have. But so let's now sort of, let's translate this over to observables. So iObservable has been around for a while. It's essentially just like a publish subscription model that's inside the core framework of .NET. And then ReactiveX is more of an expression of how to interact with those observables. So let's kind of look down, let's break down kind of what an observer is here, right? So it's essentially an observer pattern, right? So that's what, it's the same thing as, fundamentally it's the same thing as an event. Like an event is effectively an observer pattern. So you have your event here, your handler and your publisher. And then that's analogous to this right here, right? So you have your observable that is watching, that's doing the same thing. So you have the same idea, effectively. You can do the exact same thing with both of those at the base layer and get your data points. But the exciting thing now, so this is where the exciting points of everything comes into play. Because with an event, you don't really have anything, right? You just have an event. But now, with an observable, you have a representation of that event. You actually have like a data object that you can do things with. So it's the difference between having like, one item from a list instead of other than having, say, the entire list that you can now operate over. So that's kind of where your differences come into play. So you can think of the observable very much as the iterator pattern. So this is taken from reactivex.io, which is one of the main sources, which is a really good source that has a breakdown of all your operators and everything. So I have a link to it there at the bottom for you. But yeah, it's effectively the mapping your observable idea to the same things you can do with an iterator. So there's almost a perfect one-to-one comparisons there. So when you iterate, so an iterator is like IEnumerator. That's the equivalent. IEnumerator is what's equivalent to iObservable, basically. So anything you can do to an IEnumerator, you can do to an iObservable. So that was like, remember when Link first came out, and everyone was super excited about Link, like Link over objects and Link to SQL, and then they were less excited about Link to SQL, but Link was still exciting. So then you have, so effectively you have your retrieve data, which is on next. So that's as each of your data points come through. And then that's where it kind of stops as far as where observables become more exciting than your events. So you get these other things. So you get an error, for example. If your event that you're observing manifests an exception, you can deal with that as part of the observable. So as part of the data flow of the operation, you can indicate, hey, there's this event through an exception. So for example, a web request. If a web request is occurring and it throws an exception, because the internet goes down or something similar to that, then you can effectively catch that and deal with that within that construct. So it makes your code a lot more robust. And then you also get this idea of completion, where you can fire, if somebody has indicated that they no longer care about the data points, you can then act upon that. And then all of those things become features of how your data, how you interact with your data. So the neat thing, so here's kind of some more comparison points. So here you have, so this is also taken from ReactiveX. So as you can see here, you have your iterable, which is your left, so that's like your IEnumerator, and your right, which is your IObservable. So one is getting data from local memory, so that's going to be maybe like a synchronous operation where you just have your data is realized at the top, and your right one is from like network, so it might be a slower data feed. So there you can see you get these same ideas over your event streams, which is just, it's super powerful. Right? Neat stuff. So, all right, let's kind of talk, let's break down how, like, the building blocks of your observables a bit here. So this is the basic idea of how you build up your observable. So as you see kind of in that first step there, you see the familiar subscribe and unsubscribe. So that's just kind of articulating that's just telling, it's not that exciting, it's just passing two different functions to the observer so the observer knows how to deal with subscriptions and unsubscribes so that it can containerize that behavior within your observable. So here's sort of the comparative versions of those, of what those represent. So subscribe is effectively invoking that top guy, the top one clicked, and saying, okay, now I care about my events. And then the bottom one there is now disposing, which is then unsubscribing. So, this is where it starts to get really powerful, right? Because you have this whole representation is encapsulated in familiar pattern structures, right? So you have IDisposable, which we've all used, and we have logical data structures and ways that we can use those more effectively than just, say, unsubscribing. So kind of some really cool ways you can do that. You can easily manage these lifetimes. So like remember before where you have to make sure to unsubscribe. So like in Xamarin Forms, for example, if you're changing out an element, or if something new comes in that you want to subscribe to, and you don't care about the old thing anymore, right? You have to do this thing where you like unsubscribe from the old one, subscribe to the new one, and then you also in sort of your dispose point have to make sure you're unsubscribing from those events as well. So that's what's neat though, is that your entire event observation management system can be articulated through disposables. So ReactiveX has a lot of these things here. I kind of wish they would just pull into the .NET framework, but for now, in ReactiveX, you have these things like composite disposable. So the idea there is you can aggregate all your disposables into a single data structure, and then that data structure now you can just dispose of once the lifetime of the containing class is gone, and now all your event management is taken care of, right? So you can attach like your property change subscriptions there, your text change subscriptions, and then you just dispose of it. So it's neat because you're getting these object concepts that you can apply to your events. So it's nice. I like it. You get, so like for example, like I was talking about before, where you have an instance where you have an old element that you're subscribed to, and then like a new element comes in that you don't care about it. A new element comes in, so you don't care about the old one anymore. So it has like these cool concepts here with like a serial disposal, where anything that you assign to that will automatically dispose of the thing before it. So in these kind of ideas here, you don't ever even care, you don't have to unsubscribe from what kind of came in there, which is really neat. But you know that this is the new hotness that you care about, and then once that comes in, you just get rid of whatever was there before. So then that allows you to kind of set up these really cool expressions of what you want to do, right? So a lot of this comes down, because a lot of the stuff with the Reactive, which is really nice, that it comes down to is having all of your intent in kind of like a single location. Like event management is very callback based. So it's not as bad as, say, you don't get in as bad scenarios like total callback hell, but it's still kind of the same thing. You know, it's callback management and then interacting all these different callback scenarios. So you have the same thing with kind of how you manage the lifetime of it. But you can effectively set up, has everyone here done Xamarin Forms stuff? Just, all right, mapping logical modeling here. So you have this idea now where the entire span of the way you can manage the entire life cycle of something is just right there in that middle part, you know? And that's everything you have to do. And once that's kind of set up there, now anytime you come in and you have an element change and you only care about the new element, assigning a new disposable causes the previous one to dispose. So now all of your events are totally unwired. And then now you start wiring up your new ones. And then in your dispose, you just have a single serial dispose, which is your class level managed resource that you're disposing of. So now, you know, you don't have any of this sort of, there's not this complexity of management as far as like your event handling. So this actually was the first thing that got me into reactive programming, was the disposable management. I think it was like a year before I even used anything else. Just because I had a Silverlight application that was having some subscription issues, and then I kind of happened upon this stuff. So I don't know. This stuff is cool. The disposables make me super happy. So these are kind of still mapping some of these ideas, which are really neat. So like here, remember that before when you wanted to only subscribe to that one event, and you only wanted to see it once? With Reactive, you can do that entire concept here with this one expression, right? So all this does is it says, I only want one value from this property changed, and then at that point, I want you to get rid of it. So, I mean, that's awesome right there, you know? Take one and then switch, which is a little trickier to understand, but those are just enough reasons to use it forever. It's nice. I like it. So that's kind of the breakdown of how the operations work. So I have a couple demos of utilizing these, kind of realizing these in code a bit more. But I wanted to sort of give some concept prep here as well to some of the types of reactive structures that we're using, just so it makes a little more sense. So one of the ways you kind of describe stuff with reactive is by using marble diagrams. So there are these ideas of seeing your input and how what the output is. So the top two here, just to kind of, this is the vernacular for most reactive information. So anytime you see reactive operators described, they're always described in this format. So the idea here is that the top two things are data streams, and then the bottom one is what your subscriber sees. Yeah, so merge would be two subscribers. So like if you were subscribing to, say, a text change event on a username box and a password box, for example, you would, anytime either of those change, this is sort of what your output would look like. So these are some of the operators I used in the demo. So I just kind of wanted to make sure they were understood before I moved on. So filter, This is basically like a where. So on link to IEnumerable, it's just like a where. So effectively, any event that comes through, simple enough to understand, right? Debounce. So this is the other really cool feature. So this is throttling your inputs. So in this example, what they're demonstrating here is that they only want the most recent value to come out after a certain set amount of time. So you can see there's a lag between 1 and 5 because 2, 3, and 4 are happening so close together that 5 is now coming out. So this is kind of the quintessential example for reactive stuff. So cases where users are doing like search, with Google when they're typing and they're autocomplete, but you don't want to like kick off a web request every time. So that's effectively what this is demonstrating, which we have an example of. And then take until is our last is the last operator that I use. So take until is really neat because that's, for example, with like a web request. So like let's say a web request is kicking off, and then the user starts typing again, or they say cancel, like they don't want it to happen anymore. So all of those are sort of another event points that you can enact, and at that point it cuts off your stream anymore. So that's like a really simple way to say cut off if you don't want like a web request or something like that to finish. So that's kind of the breakdown of the observable stuff. So let me switch over. Oh, let me end the, hold on one sec. Cool. Let's see. I'm assuming is that too small? Yeah, all right. Let's see, I'm realizing, there's these things you do when you realize that you've never done these in the demos before. I've actually never increased the font size on VS Mac before. Let's see. What? View? I'm trying to do my Windows stuff here. Oh, there we go. I'm guessing that's it. All right. All right. I was trying all my gestures on the pad. I did the swipe, I did 2 fingers, I did this. I don't know. I didn't happen upon it, I guess. So, all right. There we go. Okay, yeah. So I was just on Windows where you just hit Control and split it up. All right, so is that, everyone can see that all right? So let me run the demo real quick, just so we have context of what we're doing here. So this is kind of a basic application. It's just like a login, log out. It's just a login, log out idea. Yeah, so I have a below I have a set of events that are occurring. So this is effectively the data stream of the observables. So all the events that are happening with the observables. So here we have a login. So this is username and password that I should have put placeholders on. But, so the idea here, you can see if I hit a letter, there. So I hit a letter, and at that point it's validating the input. And now you can see that there's kind of this delay, right? So if I hit O, there's a delay. So the idea behind that is that you're not, that's that debouncing that you're talking about. So if I type in the username and the password, there, you can see that once that validation happens. So that's just, we'll kind of break down these structures once I get in there, but that's the idea behind it. So yeah. So pretty exciting. Now we have a simulated for login. So the idea here, I click login, it starts a web request, and then at that point you can log out. So, and there's kind of an additional, let's see how many times it takes before this triggers. So I have a randomizer in there to randomly generate errors. There it is. Cool. So you can see here what happened is that I clicked the login. It generated an exception, so like the web request exception. And then it said, OK, let's just try the web request again. And then at that point, it then logged me in, right? So the other aspect of this, which is neat, like let's say the user wants to cancel it. So if they click login, they can click cancel. And there you can see now it's no longer processing the data, right? So that because there's an operation kind of canceling that. So this is sort of to demo. Yeah. So this is the idea behind. This is the code. Yeah. So the idea behind this, to kind of break down the structures, since we've all seen a lot of these things, is that this is the composability aspect of observables. The composability aspect is that you have this representation of your events as these single data streams that you can then start to intermix to articulate the behavior of your application. So if we have the app, what are all the event streams on here, right? The event streams are, we have the entry on the top, we have the entry on the second field, as the user types. We have the login button click, we have the cancel button click, and we have like the web request. So we have effectively 5 different events, streams that we need to describe, right? So we can break these up into their reactive parts. So we have, these are all pretty unexciting. This is that same stuff you saw before, which is basically just saying, hey, I want to create this observable that's listening to the clicked event. So this is the core aspect of this that's exciting. So we create an observable for each of these different elements. We have our login, so that's when they click. We have our logout, that's when they log out. We have our cancel, that's when they click cancel. We have the text change here, which is when they're typing in the username. And we have the password here when they're typing in the password. And then we make a fake web request call. So this is just demonstrating, it's essentially just waiting 2 seconds. And then once it finishes, it generates an error if some random number equals 2. Yeah, so that's our application. That's an observable representation of all the events that can occur in the application, right? So now this is where the composability aspect comes into play, which is really cool. Is that you can now all of these different observables can kind of take a life of their own. So what we can do here, so the entirety of the logic that you see there is embodied with a fairly simple amount of code, right? So here we have, this is our validation code. So now what we do is we're building up additional observables on these other observables, right? So that's what's the composability aspect of it. So the first one is we say, okay, we want an authenticated observable. The authenticated observable is the user clicking login and clicking off a web request. So now we've composed these 2 ideas of observable events. And we've now merged this data stream with a logout. So if a user clicks logout, then that's saying, hey, I want you to log out. So, we have the entire authentication state of the application represented by a new observable, authenticated, right? Authenticated observable. So that's the only observable we care about at this point. So that's how, now we can use that observable anywhere else where we want to ask about what is the user authenticated, which is neat. So, and then here we have our validation. Our validation is a composition of our username and our password there, which is nice. So that essentially comes in. It says, hey, these are the data points that represent the validity. It transforms those events into a true or a false value that we can now use to say, okay, what is the state of the events that have been coming in, right? So then this lets us now put together, now we can put all of this stuff together. This is where kind of like the functional reactive programming aspect comes into play. We can now put all these different observables together into one nice little place here that describes everything that's going to be happening. So this is the part of it that's really neat, because with this application, you can get a perspective scope on all of the logic just by being right here in this code point. You know, there's no having to jump around or anything. It's an immutable location based on immutable data to modify how these data points work. So it's nice because you can. It's a nice, easy way. See, so like the data that comes in, this result value here is an immutable structure, and then based on this data, you know, authenticated observable. So what this is doing here is saying what your authentication state is, whether you're authenticated or not. Valid is saying whether the credentials they entered are valid. And then based on that, you set up the visibility of your application. So yeah, so you can set up like the visibility of your application, right? So it's neat. So let's see, so that we can get, I have one more demo real quick, just kind of a small one. So this is kind of ooh, a little too big there. There we go. Does everyone see that all right? Yeah, all right. So this is kind of, I have these up in like GitHub repos. This is using a little bit of the reactive UI stuff, but let me just kind of show. This is kind of this has a few different samples that you can take a look at. Hopefully it runs. Is it already running? There it goes, all right. So a lot of these are just kind of simple things that you see. Let's look at the position demo since we're kind of we're running low on time here. So the idea of the position demo is that you're tracking your mouse pointer. This is another popular example for reactive concepts. So you push down, it's detecting that you pressed, you moved your mouse around, now it's detecting that you moved, and then you let go, and it gives you an aggregation of all your data, right? So it's neat because this whole, it's broken up a little bit because I need to have the descriptions, but it's really neat because all you have to really do, you know, you have your pointer pressed event, so you have the pointer press which says, hey, I've pressed the mouse down. Now, once this has happened, you say, okay, I want to subscribe to the pointer being moved around. So this is now the pointer being moved around. And as it's moving now, you're pulling all this data together here, right? And then the toList operator here is now able to aggregate all that data together into a single data set. And then here, the take until, that was the one operation that we were showing here, says, hey, okay, I only want you to take this data until the pointer is released. So you get this really cool interaction of all these events to say, because all you're really wanting to say is, I want to move the mouse around, and when they let go of the mouse, I want all the data that was there. So you can get all of this represented in this nice little subscription here. So this is kind of one of those main examples. So that's kind of a quick, primer into the sort of reactive concepts. There's a lot of good frameworks out there. Whoops, not helpful. There we go. Yeah, so I mean that's kind of the idea behind most of the observables. Michael's going to kind of talk a bit more about using these in like frameworks, like with NVVM. There's a lot of really powerful tools like dynamic data. So like dynamic data is a really cool platform for superpowering your lists with observables. So the idea is that you can essentially make everything an observable. Okay. Oh, I get a sign. I didn't know Yeah. So I guess real quick, does anyone have questions? Yeah, some? OK. Do you want to? Well, yeah, we'll just go up there. We'll do questions since there's 5 minutes.
So talk about the disposing of events and memory leaks and all that stuff. Talk about why observables are better in that case because they return the disposable by default.
Yeah, so I guess I would say because the management, so the question was why, with the memory leaking, why is the fact that it returns a disposable better for, say, memory management? And the idea there is just, yeah, I mean, it's the fact that the lifetime of the observable is an aspect of the subscription. So when you're subscribing to it, you get back, because anytime you get a disposable from something, you know that you have to dispose of it, right? Like that's the paradigm that we use. So that's the idea about it, is that with eventing, especially for new programmers, they're always going to make that a mistake where something's going to outlive something else because you have to understand that. But iDisposable is a very basic concept. So having that as part of the subscription makes your memory management scenarios easier. Yeah. Any other questions? Yeah? Can you use Reactive for asynchronous programming? Yeah. So the question was, can you use reactive programming with things like tasks or asynchronous programming? And yeah, so a task is effectively a one-point notification, right? So when you have a task, there's 2 data points for it. Well, there's 3 data points for a task, which is exactly like our iterator when we were sort of indicating. So when you write a task, OK, I don't even know why that's coming up. All right, so when you have a task, right, you create the task. So that's you having it in the beginning. Then you start the task. So now it's running. And then the task produces a value. That's your .results, which none of us are typing, right? And then it completes at the completion of that. So at that point, you have one data point observable. So if there's disposable creates things that work exactly against the task so that you can create an observable against the task. So then what will happen is when you subscribe to that observable, is it'll effectively start the task, and then once that happens, that kicks back a result, so that produces one value, and then it completes. And then that's another thing that's really super helpful, because if that task fails, you get this stuff with observables where you can catch the exception. So right now so for example, scenarios like async void, for example. Async void is a non-issue with observables. Like you never have to worry about async void if you're doing observables, because your task, so for example, you know how you maybe want to start an async task from a constructor or things like that, or there's these issues from those. With observables, that's not even a scenario, because you just wrap the task in an observable, and then you have the exception behavior as part of the observable with the task. So yeah, they work. They're great for tasks. So I forget who does a talk, like Jeffrey or something like that does a talk on that, talking about how tasks are super bad and you should just use observables. But yeah, I mean, once you start using observables, especially in your UI code, you'll effectively just put a facade in front of all of your tasks, because it becomes so much simpler to manage through observables. Any other questions? I'm getting the OK. Can I take one more question, or no? OK, no. I'll answer your question right after. Cool. So yeah, I'm Shane. That's my Android goes.